and today's presentation. So let's get to it. So today I reached out to Zachary Levodian from Digital Harbor Foundation because he wrote a very, very nice paper, something that I found had both psychometric interest and data science interest. And it relates to the use of retrieval augmented generation around math question answering. So without further ado, I'm going to give it to Zach.
Hello there. It is lovely to meet you all. I'm going to take over screen sharing. Let's see if we are good to go here. Looks like we're in business. If you have any issues at all, just let me know. Okay, looking forward to this. I'll admit to being a little nervous to be presenting to the AIME. I'm not sure about the pronunciation audience because I'm a computer scientist. That's my background. And that means I love to horribly misuse the work of the many lovely statisticians and psychometricians in the audience. And I love to design new education technology with no real knowledge of education research either. So I'm going to try to avoid doing either one of those things too much, in part by saying that I'm really here to learn from all of you. I think of myself first as a builder, and with generative AI, so many of the design and evaluation principles that we have are still half-baked. Please do tell me where you see an opportunity for better designed tools and more rigorous evaluation processes. I've been doing work specifically in education for about 4 months now. So while I'm pretty much an expert, I might have some blind spots, and you should feel free to put questions or comments in the chat as I go, or you can just unmute and interrupt me. This can very much be a discussion, and I'm looking forward to a nice long discussion period at the end as well. Okay. Some quick notes before I dive in. I'm presenting this work at NeurIPS in New Orleans on Friday. So if you are also there, please come by the guide workshop. It'll be a lot of fun, I think. I also want to mention that this is a collaboration with several different organizations, which we'll talk more about later, but I want to specifically point out that Cheng Liu, who's a professor at the University of Utah, and Danushka, who's a colleague of mine at the Digital Harbor Foundation, are, I believe, both here in the call, and we'll be happy to answer any questions you dump in the chat and hopefully participate in the discussion as well. You can also find the paper on arXiv, the code and data on GitHub, and I'm not going to linger because you can find all of these links on my website, which is at the bottom of every single slide. Okay, let's talk about large language models for education, and specifically math education, but some of these lessons will hopefully be more broadly applicable. There are lots of applications for text generation in education, as you all know. This group is familiar with applications in automated assessment, student feedback, that kind of stuff. And I want to focus today just on one-on-one tutoring, particularly as it's instantiated in intelligent tutoring systems. So I personally am mostly influenced by old writings of Kurt Van Lean here, so I might be a decade out of date, but I really like this concept of intelligent tutoring systems as having two loops. So we have an outer loop where a student selects a task, and an inner loop in which a student takes steps towards completing that task. And if we want to improve intelligent tutoring systems using large language models, most of the design opportunities I've seen target that inner loop. So for example, maybe we're going to use LLMs to generate hints or hint sequences in response to students' work. I'm not going to talk about hint generation today, but we actually just released a demo of LLMs for hint generation with some folks at the Learning Agency. So you should ask me more about that during the discussion if that sounds interesting to you. The second example I'm giving here is question and answer, Q&A. And Q&A sessions with human tutors are one of the most impactful learning interventions that we know about, so they're really appealing. And I like to differentiate between two Q&A approaches. So first, there's the procedural Q&A, where our goal is enhancing students' procedural fluency using strategies like step-by-step problem solving for specific math topics. And that's an inner loop kind of intervention. But the second is conceptual Q&A, where our goal is deepening students' conceptual understanding using strategies like clarifying math concepts with concrete or worked examples, providing immediate feedback on a student's conceptual thinking, and connecting math ideas to real-world problems. I'm making this distinction in part because we know large language models can be helpful for procedural Q&A, although they make lots of errors. But with conceptual Q&A, we're kind of in uncharted waters. Where I've seen previous work on this more conceptual Q&A, this is usually framed as an information retrieval problem with a traditional search interface, right? So basically, I add a search bar to my intelligent tutoring system so that I can search through the textbook more easily. And that's useful, but LLMs are super appealing here. We hopefully get factual information, but adapted to the language and framing that the student uses when they seek out that information. So our team was particularly interested in conceptual Q&A because we were collaborating with an existing intelligent tutoring system. It's called Rory, that was pretty good on the procedural side, but didn't have any built-in conceptual support for students. So if you're not familiar with it, Rory is a smartphone-based chatbot math tutor that's used by students mostly in the classroom, but also at home. It has about 250,000 students have used it, I believe. Mostly based in West Africa, especially Ghana, which is where Rory sort of started as a project of the Rising Academies private school system. Rising Academies is a participant in the Learning Engineering Virtual Institute. I work with the Digital Harbor Foundation, which is a small but growing education nonprofit. We are also supporting the Levy program, and that's how I got involved. So Levy has a goal of doubling the rate of middle school math progress for low-income students by 2027 by exploring a whole bunch of ideas. And we were excited to improve Rory by prototyping a new feature that uses large language models to provide conceptual Q&A to students. I think it's going to help to understand what Rory is in a little bit more detail. I've been hearing some pings, which leads me to believe that I can't see the chat, but maybe that's nothing. Okay, great. No, we're good. Okay, so as you can see, basically Rory is focused on this concept of micro lessons. So we're going to give these very sort of inflexible delivery of messages, images and text, with mostly multiple choice and free response questions. So these micro lessons are awesome. They really fit the context well, the sort of like WhatsApp interface. But our goal is to move beyond these micro lessons to more conceptual discussions that aren't associated with a single math problem that the student is actively working on, right? So right now, students don't really ask, oh, I've lost my advance. There we go. So right now, students don't really ask conceptual questions to Rory. I think that students' mental model of the system is that it is very rigid. That's the impression I've got from the qualitative interactions we've done with students. And so to prototype a conceptual Q&A feature, we're going to need to look elsewhere to understand what needs students actually have when it comes to conceptual Q&A. So with folks from the University of Florida who are also involved in the Levy program, we instead turned to the Math Nation forums to see what kind of questions students were asking each other. You might know Math Nation by its previous name, Algebra Nation, but basically these are just forums where we can see what kids are actually saying to each other. Their questions are mostly answered by peer tutors and teachers. And I was just interested in the question. So I went through about 500 Math Nation threads. And I can tell you the two main things posted by students are memes that range from baffling to actively offensive, and homework help requests, which I would put more on the procedural side than the conceptual side. But there are some conceptual questions as well. What is monomial? How do I add line segments together? How do I multiply fractions? How do you know if a number is a constant? Some of the questions are a bit more elaborate than that as well. I always forget the difference between commutative and associative. Does anyone know a way to make me remember? And we're going to be sticking with that last question as our illustrative example. So these are 51 conceptual questions from the Math Nation forums, and we're going to use this as our test set for our sort of first version of the conceptual Q&A feature in Rory. What I like about these questions is that they have high external validity, right? So they're relatively diverse. Students really did ask them, and they all represent a tutoring opportunity detached from the specifics of a single sort of problem set or individual problem. Okay, how does ChatGPT do answering this type of question? Well, the answer is pretty good, right? I'm not going to present any formal data on this, but the responses are generally correct. That is to say, here, ChatGPT is telling us that commutative is when the order in which you add or multiply numbers doesn't change the result. It's telling us that associative means grouping of numbers, and I would say that's correct. But is this a good answer to the question? No, correctness is not enough, right? One of the core challenges in using generated text in student-facing interfaces is that it can be correct or even helpful while still being totally irrelevant to what the teacher is doing in the class. We might want the language and concepts used in generated texts that are shown to students to reflect a student's grade level, and more generally for there to be alignment between the technology and the curriculum. We might also be concerned about cultural relevance, particularly in the case of Rory, because we know that LLMs like ChatGPT show significant Western cultural biases because of the distribution of the data they're trained on. These criteria I'm waving my hand at here are quite vague, so how can we do student Q&A that fulfills them? I think it's useful here to think about what qualities the responses need to have for us to trust them across sort of all of these dimensions. And here's one way I like to think about the design space for these systems. Let's imagine a continuum between a conventional information retrieval system and the use of a minimally constrained generative text model like an LLM. Let's assume that we have some query from the student, like a conceptual question or just some kind of information need. And then in that information retrieval context, this is just information extraction, right? So identify the text excerpt from some existing corpus that is most relevant to a student's question. And this approach has really a lot of benefits, right? The text shown to the user is by definition trusted. It has been vetted or even written by the educator, and it exists in that familiar context to the student. So it's probably correct, and it likely meets all those other criteria too, like being grade appropriate. But of course, there are downsides, as we know, to information extraction systems. They're inflexible, it's hard to personalize the response, and you're depending on your retrieval corpus to not only contain an appropriate response to the student's question, but also that your retrieval system is powerful enough to actually find that appropriate response. And it's in that context that instruction fine-tuned large language models like ChatGPT start looking really amazing because they echo the language used by the student, and they generally respond directly to the content of the question. So we've been discussing, though, you can still be totally inappropriate here on the other side. And we also might be factually incorrect while sounding authoritative, which is not a good combination. So ideally, we'd like to tune between these two extremes. And there's a long history of hybrid models that do exactly that. Large language models are new and flashy, and in particular, their fluency is so much better than the previous generations of models. We might want to lean as close to the ChatGPT side of things as we can. And there are so many approaches that we can use to think about this kind of problem. There's a ton of research on this topic last week at EMNLP, this week at NeurIPS. But I'd argue that currently the most prominent approach is to use retrieval-augmented generation. When I'm talking about retrieval-augmented generation, I'm talking about a combination of prompt engineering as a technique and a retrieval system. So I'm going to assume that we're all at least abstractly familiar with the functioning of large language models, where we provide a textual prompt to condition the model's generated response. In that basic use case, we do prompt engineering, incorporating the student's question in the prompt in some way until the generated responses start looking good. Retrieval-augmented generation is an extension of this approach that incorporates a retrieval system. So now we take the student's query, pass it to a retrieval system, identify one or more texts from within this corpus, and use those retrieved texts in the prompt before we pass it to the large language model. Before we go further, I want to go into a quick sidebar on terminology. In the 2020 Facebook paper that proposed retrieval-augmented generation as a term, they used it to refer to an underlying LLM trained either sort of from scratch or fine-tuned with retrieved documents alongside whatever your task texts are. The term has come to describe any combination of LLMs and document retrieval, including the high-level kind of process that I just described. So here's Luca Soldani at AI2 lamenting the use and abuse of this terminology. And unfortunately for Luca, I'm going to continue this trend since I'm not talking about any kind of fine-tuning or training process. I'm talking purely about in-context learning, where we're trying to generate better responses entirely by adjusting the prompt that's given to the model. So rather than retrieval-augmented generation, the term retrieval-enhanced machine learning is probably just strictly more appropriate. This was proposed by Google researchers at SIG-IR last year in a viewpoint that I would definitely recommend checking out. But we will not be changing the world today. Okay, sidebar over. So tangibly, to do retrieval-augmented generation for this problem of conceptual math-related Q&A, we need to add a retrieval system to our architecture. And to do that, we need to make just tons and tons and tons of small decisions, because the technique here is so general You can use it for any kind of text generation task. Learnings from one task context might not generalize to the specific thing that we're trying to do. And the theory of why RAG works to improve the quality of generated responses is pretty bad. It's really unclear. It's basically the theory of why in-context learning works. So that includes techniques like few-shot prompting, think step by step, and other prompt engineering stuff that you might be familiar with, as well as more complex approaches like tree of thought. And the evidence is pretty unclear, but my personal underinformed summary of that literature is that including texts in the prompt is a very stupid way of approximating the posterior predictive distribution, right? It gets us into the right probability space. And so intuitively, that means that RAG is going to be useful for essentially providing formatting and language that we want our answer to contain. And that means it matters what texts we put in our retrieval corpus and how we format those texts when we retrieve them and include them in the prompt. But of course, it also matters what our prompt is to begin with, what retrieval system we're using, and what large language model we're using. We can think of all of these decisions as hyperparameters. So ideally, we would have some kind of automated evaluation system, and then it would be easy to try a bunch of different combinations and end up with something reasonable. And I'm basically going to spend the rest of this talk complaining about evaluation and why we basically can't do that yet. But for now, I want to make it clear how we implemented our system and walk through some of these many, many decisions. So let's start with the large language model and the prompt. So we used GPT 3.5, and that's basically for cost reasons and speed of development. It's a real factor for incorporating it quickly into any kind of ed tech product. We want it to be able to scale, and like the costs sort of maths kind of work out that way. Notably, that means you might be able to do better with more complex models or fine-tuned models and so on. Then to generate responses appropriate for the Rory context, we then choose a base sort of system prompt. This is what we used up on the screen now, and it seemed to work pretty well, although it can certainly be improved. So this is what we used to generate that response we saw earlier about commutative and associative properties as well, by the way. So the more interesting sort of decisions that we have to make are not then on the prompting side, they're more about on the retrieval side. What text corpus do we want to use so that we have a shot at improving our responses compared to just using this prompt here? So let's lean on this idea of using sort of a vetted, trusted corpus. And so we're going to use just a single math textbook. And so we used the pre-algebra textbook released by OpenStax because it's trusted, it's high quality, and it's freely available under a permissive license, which matters too. There's also another benefit to using a textbook. It's structured, so it comes with semantically related chapters, sections, and subsections, and we can actually exploit that structure when we retrieve texts. So to actually do retrieval with this textbook data, we need to index it in some way so that we can identify the most relevant sections based on a student's query. And to do that, we again relied on OpenAI APIs. So their ADA embeddings are a way to get a dense vector representation of both the student's query and the individual subsections of the textbook. We can then get a ranking of the most relevant sections of the textbook by computing cosine similarity between the vector for the query and the vector for all of the textbook subsections. So the pre-algebra textbook we use has 247 of these subsections, and we're going to produce a score for the similarity of each subsection. It's quite quick, actually. It adds less than 200 milliseconds of latency on average, including the API call to embed the query. And then once we have the relevant scores, here's where we get to exploit the textbook structure because we used an approach that's called parent retrieval or parent document retrieval. So rather than just providing the single subsection that's most relevant to the query, we include the whole section. So the full context of that subsection is available to the system at inference time. So here's our query from before about commutative versus associative properties. And then by cosine similarity, the most relevant subsection is within section 7.2 of the textbook with the header simplify expressions using the commutative and associative properties. Okay, that seems pretty reasonable. But we don't just include that one subsection. We include all of the subsections in 7.2, so all of 7.2. And then we pass that whole section into the prompt and we pass it through to GPT 3.5. Okay, so which one of these responses is better? The original one on the left or the one that uses RAG on the right? Okay, I'm obviously just kidding. I'm not going to leave 10 paragraphs of text on the screen. So the question in general is, how can we tell that we've improved things? So on our Q&A continuum, have we actually moved toward a more trusted, vetted, student-appropriate response? Well, this is a well-studied notion. People in information retrieval and generative text systems, they generally call this construct groundedness. And as a construct, it's definitely not going to capture everything we talked about earlier, but it will at least help us understand if we're moving in the direction of responses that are grounded in our vetted, trusted textbook. So I want to talk now about how we can actually determine that our responses are more grounded, basically by using a bunch of automated groundedness metrics that the IR people have come up with. So let's consider a relatively simple one, knowledge F1. This might be familiar to you already. This is a bag of words based metric where we tokenize the response generated by the LLM, and then we also tokenize the section of the textbook that we included in the prompt. And then we basically ask, what is the overlap between these two sets? So we compute precision and recall with retrieved text as the ground truth and the generated response as the prediction, then take their harmonic mean. So one observation about KF1, as it's often shortened, is that it's quite strict, right? You get no credit for synonyms, and you get punished for being wordy in your response. And one particularly punishing aspect of KF1 for LLM evaluation is the tendency of instruction fine-tuned language models to repeat words from the question in the response. Who is the first president of the United States? The LLM will respond, the first president of the United States is George Washington, and not just George Washington. So we actually might think that the first response is better, and we can avoid punishing that type of response by using a variant of KF1 introduced this year by some folks at Alana AI that removes the words in the query from the retrieved text and generated responses bag of words. Okay, so now we have at least one automated groundedness metric in place, and now we can evaluate the responses over all 51 of our student queries from Math Nation. We can then take the mean, we get a score for this particular system configuration, so 0.29 in this case. Okay, if we're already using RAG, then what tools do we have at our disposal to make the responses more or less grounded? Intuitively, we can do prompt engineering, right? GPT 3.5 is trained to follow instructions. So we can just include instructions in the prompt to be more grounded. So this was the original RAG prompt that we used. We say, use examples and language from the section below to format your response. What if we just update that to be more instructive? We instead say, reference content from this textbook section in your response. And lo and behold, if we compare the means, groundedness increases. Okay, so this is great because it means we can just manually adjust the prompt to achieve the desired levels of groundedness. We can now compare the level of groundedness between conditions. So here are the three conditions that we sort of tangibly considered in this study and that I'm going to talk about today. So none is sort of like base default GPT, no RAG at all. Low is that first prompt, and high is the second prompt. So these correspond to the level of prompting guidance that we provide to the LLM in order to induce this groundedness property, right? So the same sort of pattern holds for two other commonly used groundedness metrics that we looked at that are model-based, BERT score and BLERT, but I'm just going to use KF1 as our punching bag here. So this all looks pretty good, but I personally have trust issues with automated metrics like this, because for groundedness, it seems like we might be able to increase the value of the metric, but without a corresponding increase in the things we hope groundedness correlates with, like correctness. So here's a fourth condition added that doubles our KF1++ score. The problem is, I know that these responses are garbage. I call this the cheater condition because it just updates the prompt to say, given a middle school math student's question, you will identify the most relevant section from the textbook. So in general, this should make us a little concerned. Not only do we need some other way to tell if we're increasing groundedness in a good way rather than in some kind of pathological way like the cheater condition, we might also worry that there's going to be a trade-off with other things that we care more about, like the relevance of the response and its correctness. And actually here, that work from Alana AI gives us a very useful perspective on groundedness by distinguishing it from another construct that they call faithfulness. They say that they consider a response to be grounded when it, or a paraphrase of it, is found in whatever document is retrieved. And they consider a response to be faithful if, in addition to being grounded, it answers the question and follows from the dialogue. But we don't have good automated metrics for faithfulness. In fact, we don't even have good evaluation processes for faithfulness. This is a great opportunity for future work and for interdisciplinary collaboration between the measurement people and the design people. We will talk more about this as we move into the discussion later, I very much hope. And I hope someone thinks, that's solved. I would love to hear it, please. So in the meantime, we can try to better understand how retrieval-augmented generation affects the quality of responses by asking people, which is something I'm always a fan of. So we're collecting data from students, soon TM, but for this work, we just asked educators at rising academies, and of course several members of the research team, to basically annotate for two constructs. So first is a comparative preference ranking, because the main thing we care about is how RAG affects the quality of responses, right? So we present people with different LLM responses to the same student question and ask our annotators to rank them. We also want to know how much we can trust our automated groundedness metrics. So we used an existing groundedness scale and essentially use this as a manipulation check, right? Does the automated groundedness track with perceived groundedness? So the top line result, do keep in mind that this is just 51 Math Nation queries annotated by adults, is that first, retrieval-augmented generation can help, right? So respondents did prefer RAG-generated responses in the low guidance condition over responses generated without RAG 57% of the time, right? So the second conclusion is the opposite of RAG can help. It's that RAG can hurt, or rather too much RAG can hurt. So respondents preferred low guidance responses over high guidance responses 64% of the time. Okay, does using RAG actually increase groundedness? Well, no real indication that it does in the low groundedness condition, right? So respondents could definitely tell that the high guidance responses were more grounded, but not so in the low guidance condition. So thinking just about that low guidance condition, we saw that RAG responses were preferred slightly more than responses generated without RAG. And it might increase perceived groundedness in some cases. Okay, I call that a win, right? So RAG can probably help, and it probably won't hurt. That's important because we maybe would want to use RAG even if it did hurt response quality, right? If we care more about groundedness than about human preference, then we can use prompt engineering to make that trade-off, which is a really, really nice sort of design knob to have access to as a systems designer. And by the way, we can compare the human annotations to our automated groundedness metrics as well. The correlation is 0.52 between perceived groundedness and the KF1++ score, which actually seems pretty good to me. So that should increase our trust a bit in using the automated metrics, even though they have sort of pathological cases. This is all quite preliminary work. That's why it's a workshop paper, but we ought to understand what the qualities of the prompt are that lead to higher or lower perceived groundedness, and then higher or lower sort of preference for that sort of condition. So let's just look at one obvious thing. How relevant is the retrieved textbook section to the student's question? We annotated for document relevance as well. So we used an existing 4-point scale. And we do see the expected relationship, right? So responses with more relevant textbook sections in the prompt are also perceived by humans to be more grounded. That's a 0.56 correlation. But there is basically no correlation between relevance and preference, which is very surprising. We might think that the reason high guidance responses are bad is because the retrieved text is low relevance. After all, large language models can be easily distracted by irrelevant context. But it doesn't seem like that's what's happening here. So there's a few sort of mysteries to untangle in future work. So currently, we're continuing our exploration of retrieval-augmented generation. We're testing these Q&A sorts of processes for conceptual, but also some variants of procedural with students. I actually think we have an in-classroom test happening in about 12 hours with a new condition. So we're really excited to start getting actual preference data from students, as well as to see whether our preference results hold beyond that first conversational turn of a Q&A session, which is what we've been talking about, right? You ask the LM the initial question, you get a response, but then ideally you ask follow-up questions if you want to clarify something. I'll also want to point at the end here to two compelling research directions that I hope others might have thoughts about or want to pick up in the future. So the first is the straight design consideration. How do we best incorporate these kind of Q&A features in otherwise sort of static, structured, procedural, intelligent tutoring systems like Rory? And then the second is an evaluation question, which is how can we create repeatable processes or automated metrics for capturing groundedness, correctness, and trustworthiness? I want to end by pointing to a nice paper laying out some of the major open opportunities for research in NLP right now that points to these kinds of evaluation things as a really major open opportunity. And here's Manal, researcher at Google, complaining about the quality of evaluation, which is very much my observation as well. If we had good processes for evaluation, we could iterate a lot more quickly. We could make these decisions in a much more principled way. Okay, I think that's all I wanted to share with you today. So now I'm hoping we can chat about some of the issues that I raised. I see there's some stuff going on in the chat that I haven't looked at. Maybe we'll take a look there.